This is Module 10, Practice Problem number 3, and it's a problem that demonstrates that if you're in the lab and you have two aqueous solutions, two test tubes full of a liquid, and you want to make aluminum sulfate, which is a solid, how can we do that? And so given in the problem is this chemical equation where we have 3 moles of sodium sulfate, and we want to add that to 2 moles of aluminum nitrate to form aluminum sulfate and sodium nitrate. And then in the problem it gives you the rest of the information. If we take 690 milliliters of a 2.50 molar aluminum nitrate solution and add that to an excess amount of sodium sulfate, we want to know how many grams of aluminum sulfate will be produced. Okay, so this type of problem relies on the fact that you have memorized your polyatomic ions, and you are remembering charges, and you know what the atomic symbols mean. There's just a lot going on here, and so you want to take it slow and take each bit of information as it comes. So sometimes it's just nice to start. What do you want to know? What is the question asking for? And so we look down here. We want to know the mass in grams of aluminum sulfate that will be produced. And so in the problem it states it in word form, and so you have to be able to translate this aluminum sulfate and know what it's talking about. And if it's produced, we know it's going to be a product on the right hand side of the arrow, and we know that aluminum sulfate is Al2 and SO4 3. So this is what we want to know. This is what we're producing, and we want to know the mass of this that is produced. So what else does the problem tell us? We know that we have 690 milliliters of a 2.50 molar solution of aluminum nitrate. So remember this capital M, when we talk about molar, this is talking about the molarity, the concentration of aluminum nitrate. And aluminum nitrate is this molecule right here, AlNO3 3. And we have excess of this molecule, sodium sulfate. So this is really just kind of a bystander. We're not really, don't have to use this for any of our purposes, other than to know that it's not the limiting reactant. All right. So the other thing to keep in mind when we see a chemical equation, it's a ratio of sorts that relates the ratio of moles for each of the substances in the chemical equation. So for every 3 moles of sodium sulfate, we need 2 moles of aluminum nitrate in order to make 1 mole of aluminum sulfate and 6 moles of sodium nitrate. But if we look through our problem, nowhere does it tell us the number of moles. So we have to use the information that we're given to first determine the number of moles that we have in order to establish the relationship between these molecules. And the only thing we know is something about aluminum nitrate, which is this molecule here. So the other thing we have to keep in mind is what exactly is molarity. Remember that molarity is simply a measure of concentration that relates the number of moles per liter. All right, and so we know that we have 690 milliliters of a 2.50 molar solution of aluminum nitrate. We can use this information now to find out how many moles of aluminum nitrate do we actually have. But before we can do that, we have to first convert this 690.0 milliliters to liters. Okay. So we want moles. We're going to have to determine molar mass, and we know that for every 1 liter we have that is equal to 1,000 milliliters. For every 1 liter there are 1,000 milliliters. So we can use this relationship here to first determine how many liters do I actually have when I'm talking about 690.0 milliliters. So I take my 690 milliliters and I'm going to divide that by 1,000, and the milliliters will cancel, leaving me with 0.6900 liters of a 2.50 molar solution of aluminum nitrate. Now, notice that I had to keep these two zeros at the end because I need 4 significant figures. In my 690.0 milliliter solution, in this I have 4 significant figures, and so my answer must have 4 significant figures in the answer. The other thing to keep in mind when I read 690.0 milliliters of a 2.50 molar solution of aluminum nitrate, this of in a word problem always means multiplication. So if I take 690 milliliters of this 2.50 molar solution of aluminum nitrate, how much do I actually have? How much aluminum nitrate is actually in this 690 milliliters that I'm taking? So what I can do is, instead of reporting the molarity as molarity, to remember that this is moles per liter. So I can come down and I can take my 690 milliliters, which is now converted to liters. So I have 0.6900 liters, and I'm going to multiply that by my 2.50 moles per liter, my concentration of aluminum nitrate. And the answer that I get is 1.725 moles, because my liters will cancel and I'm left with moles. So I have 1.725 moles of aluminum nitrate left. Now there are how many significant figures here? Right in this answer there are 4. And while that's true for 0.6900, there are only 3 significant figures in 2.50. And when we multiply or divide, we want the least number of significant figures in the problem. So I have to round this number. I only need 3 places. So I'm going to go out to the hundredths position, but I have to look out at this number to the right of that 2 to determine whether or not I have to raise that 2 to a 3, or does it stay the same? And any number 5 and above means we increase the value. So this becomes 1.73 moles of aluminum nitrate. So when I take that sample, I have 1.73 moles of aluminum nitrate. Well, that's all well and good, but now what does that mean? It means that I have to go back and look at this equation at the top of our page, and I know that there is a relationship between aluminum nitrate and aluminum sulfate that we're going to make. For every 2 moles of aluminum nitrate that I use, I'm going to generate 1 mole of aluminum sulfate. But I don't have 2 moles of aluminum nitrate. I only have 1.73 moles of aluminum nitrate. So I can use this relationship to determine how many moles I'm going to generate if I only have 1.73 moles. So I'm going to take my 1.73 moles of aluminum nitrate, and just so that I don't have to remember which direction is which, I know that I need my moles of aluminum nitrate to cancel, so that 2 moles is going to go in the denominator, and the 1 mole of aluminum sulfate, what I want to know, is going to go in the numerator. And so this becomes a division problem, right? 1.73 moles of aluminum nitrate divided by 2 moles of aluminum nitrate is going to tell us how many moles of aluminum sulfate I'm going to generate. And I find that that is 0.865 moles of aluminum sulfate. And again, because I have 3 significant figures here, I want 3 significant figures in my answer. So I'm getting closer, right? Now I know how many moles of aluminum sulfate I generated, but the question wants to know what is the mass? How many grams of aluminum sulfate did I generate? How many moles, how many grams is the equivalent of 0.865 moles of aluminum sulfate. This requires that you know how to determine that relationship. Remember, the molar mass, the mass of 1 molecule of aluminum sulfate in AMU, tells you how many grams contains 1 mole of aluminum sulfate. So the next thing we're going to do is determine what is the molar mass of aluminum sulfate. So we know that in this molecule I have 2 aluminum atoms, 3 sulfur atoms, and 12 oxygen atoms. So when I look at my periodic chart, I know that the atomic mass for 1 aluminum atom is 27, 1 sulfur atom has a mass of 32.1 AMU, and 1 oxygen atom has a mass of 16.0 AMU. And then I have to find, but I don't just have 1 of each, I have 2 aluminum, 3 sulfur, and 12 oxygen. So I simply multiply by the number of atoms I have. So I had 54 AMU of aluminum, 96.3 AMU of sulfur, and 192.0 AMU of oxygen. And when I add that together, I know that the molar mass of 1 aluminum sulfate molecule has a mass of 342.3 AMU. And all this does for us right now, so that's the mass of 1 molecule, but it also tells us that if I go into a lab and I weigh out 342.3 grams of aluminum sulfate, that mass will contain exactly 1 mole of Al2SO43 or aluminum sulfate. So here's that relationship there. 342.3 grams of aluminum sulfate contains or is equal to 1 mole of aluminum sulfate. There are 1 mole of molecules in this 342.3 grams of aluminum sulfate sample. And now we can go back and we know that we have only 0.865 moles of aluminum sulfate, and in 1 mole I have 342.3 grams of aluminum sulfate. So we multiply our sample by 342.3. This allows us to cancel out our moles of aluminum sulfate, and the resulting answer is 296.0895 grams of aluminum sulfate. That's a pretty detailed number, so we have to go back. There are 4 significant figures here, but only 3 significant figures in our original moles of aluminum sulfate, so our answer can only have 3 significant figures. And so I'm going to go out to our 1's position, but I look at the 0. That means the 6 will remain our 6. Our final answer is 296 grams of aluminum sulfate. So 296 grams of aluminum sulfate will be produced if I use 690 milliliters of a 2.50 molar solution of aluminum nitrate. I will have 296 grams of aluminum sulfate that will precipitate out of solution and be formed in this particular problem. There are lots of steps to follow, and you just have to keep track of everything that is going on. Thank you.